The Threads and Spinons theory. Full paper in the description. Why theoretical physicists fear new theories. A call to courage and exploration. Theoretical physics is a discipline that boldly explores the universe's most profound mysteries. Yet, paradoxically, it is also a field that often resists transformative ideas. Why? Because the very structure of academia and the scientific community fosters a culture of caution rooted in comfort zones and the fear of challenging established giants. This article explores why physicists resist revolutionary theories, how this mindset hinders progress, and why the essence of physics demands the courage to move beyond the familiar. The comfort of classical physics. From the earliest stages of education, budding physicists are taught to revere the classics. The theories of Newton, Maxwell, and others form the foundation of their understanding. These ideas are elegant, deeply ingrained, and often backed by robust mathematical frameworks. Students who master these theories and their mathematical formulations are rewarded with academic accolades, scholarships, and eventually PhDs. By the time they reach the pinnacle of academia, these physicists feel a deep compatibility with these established ideas. They have built their careers on them, taught them to countless students, and published research that aligns with these frameworks. Stepping outside this comfort zone to challenge the principles defining their success is daunting. Why risk everything to explore an uncharted path? Professional pressures and fear of repercussions. The resistance to new theories is not just personal but institutional. Academic funding is often tied to research that aligns with established paradigms. Proposing a theory that contradicts Einstein or quantum mechanics can be risky, even reckless. The fear of losing grants, tenure, or professional credibility looms large. This dynamic creates a self-reinforcing cycle. Young physicists, observing the struggles of those who deviate from the norm, learn to play it safe. The result? A community that prioritizes incremental advancements over revolutionary leaps, favoring mathematical elegance over physical insight. The fourth dimension, an intellectual escape. One striking example of this resistance is the increasing reliance on abstract, higher-dimensional explanations in theoretical physics. Concepts like string theory and multiverse models dominate the landscape despite lacking empirical evidence. While mathematically sophisticated, these ideas often serve as intellectual escapes, ways to avoid confronting foundational questions about the nature of reality. Einstein's popularization of spacetime as a tangible fourth dimension exemplifies this trend. While the concept offered a new framework to interpret gravitational phenomena, it also introduced an almost mystical reverence for a dimension that remains unobservable and unmeasurable in practice. This blind acceptance of spacetime as a physical entity rather than a helpful model has led many physicists to treat it as unquestionable. Einstein's ideas, though influential, have become a crutch for many, overshadowing the contributions of physicists who focus on fundamental particles and direct observations. The essence of physics, a call to exploration. Physics has always been about questioning the status quo. Galileo challenged the Church's geocentric model. Newton redefined motion and gravity. Einstein revolutionized our understanding of space and time. However, while Einstein's work was groundbreaking, it is not infallible. Placing his theories on a pedestal hinders progress and discourages critical inquiry. Real progress in physics comes from exploring tangible phenomena, focusing on particles, fields, and forces that can be observed and measured. Theoretical physics must return to its roots, prioritizing empirical evidence over abstract constructs. Lessons from the past, overcoming resistance. Historically, many groundbreaking theories were initially dismissed. Copernicus's heliocentric model was ridiculed, and even Einstein faced skepticism when he proposed general relativity. These examples remind us that resistance is part of the process. However, persistence and empirical validation can overcome even the most entrenched skepticism. The role of paradigm shifts. Thomas Kuhn's concept of paradigm shifts explains why science resists new ideas. Established paradigms dominate until anomalies accumulate, forcing a re-evaluation. The Threads and Spinons theory could represent such a shift, challenging long-held assumptions and addressing anomalies in current physics.